Okay, here we go. You have 1,200 meters of fencing to enclose 3 rectangular pens. So there's your drawing. You need to make 3 rectangular pens for animals. But one side is along an existing wall, so you don't need to put fence on one side. Do you remember this?
Isn't there a different way to organize the 3 rectangles?
Like?
Have 2 of the pens beside each other and then the 3rd one below both of them.
Oh, I think that, I guess we are going to assume that they're all like symmetric, like
The
same.
question doesn't say that.
Yeah, I know him. Okay, we're trying to find the max area, so what I'm going to do is I'm going to label some stuff here. I'm going to label some lengths and widths on my diagram. Okay, so here we go. I got 1 of the lengths and 4 of the widths, and together that would total 1,200. Okay, which letter out of these would be the easiest to isolate? An L or the W? The L. Okay, so there's that. If I had not a wall here, I would have had 2 L's. You guys would have algebraically divided everything by 2, right? Would that have made sense? Okay, so let's talk about area. Area of a rectangle is a length times a width. And I'm trying to maximize this area. Okay, so this is not appropriate to have 3 different letters in an equation, right? You always have your 1 here, and then you can only have 1 letter on the other side. So what you're going to do is take this and substitute it in there, right? Do you remember this? Exact question, grade 11. So here's my equation for area. I'm going to distribute that. What type of equation is that? What's the name of this function? All the functions you've studied. In grade 10, you started the study of functions and you did linear functions. Which one is this one called? Quadratic. Why? Because it has a squared. What's the next? When you have a cube, it's a cubic, right? So this is a quadratic. What does that visually look like? Do you remember that? Negative quadratic. Negative quadratic. Got the visual? And what are we really trying to do? We're trying to get a max, which would be there. Okay? What do we all know about a maximum here? What have we learned in calculus? Slope is 0. So that's where we're going to go. To figure this out, and we did a tangent line, right? What's going to go on with that tangent line? Slope 0. A slope of 0 will show me this max. Okay, so how do you get slope? What's your calculus process to get a slope? Derive. Okay, so I'm going to do an A prime. So this would be 1,200 minus 8W. Right? Front times top. Okay. And what did we just say? The slope here would be a tangent slope line of 0. Okay, maximize the total area. So you can do 3 pieces of information now. This is your W. You could figure out your L. You could figure out your area. It all depends where you do your plugins, right? So if I wanted my L, I would do my plugin into this. If I wanted my area, I would plug into this, or just times my length and width. That would have been another way. Okay, so 1200 minus 4 of those widths, so there's my length, and your area should have been 90,000. Okay, did you notice I put units on everything? Meters, meters squared. Okay, does that make sense? So you did a grade 11 idea, and then instead of what we would have done in grade 11, you would have done that opposite B over 2A plug-in. That's how you would have got that vertex. That's what you did in grade 11, but now we just did calculus. Okay, grade 11. You're selling tickets to an event. You're trying to make your revenue with your tickets. Okay, so revenue equals your ticket price times your people. Does that make sense? If you were selling tickets for 20 bucks and 5 people came to your concert, which is probably not a very good concert if that's what you're doing, so then you make 100 bucks, right? Just times them. Okay, so revenue equals big bracket, fill in. You're going to sell your tickets for $10 and 1,200 people come. A survey was showing us that for every reduction price of 50 cents, I need to reduce by 50 cents. So where are we going to do that? Reduce by 50 cents. Okay, I'm going to put a variable on there because I don't know at the end if I should go 50 cents or $1 or $1.50, or you know what I mean? You don't know. If you were to do this though, 100 people would attend, 100 more. But again, there's an X on it because you might have done this twice. If you do this twice, this would do a 200. Okay, you got some moves here to do on your own. You got some foiling. Okay, foil collect. Yay, nay, flowing back into your brain, grade 11? No, too long ago. Okay, so what do I know? Negative 50x squared is the boss of this function, so that's going to tell me x squared. Negative is a parabola shape, that's what the graph of it would look like, and I would have a max. And what do I know about maxes? The tangent line slope would be 0. Same idea, right? Okay, so I need you to derive, to get me that slope equation. Okay, so I derived, set my derivative to 0. Therefore, I'm going to find that tangent line at an x value of 4. Does that look okay to you? Now, that's not my answer because my question was what price would maximize the revenue. Okay, you're not going to sell your tickets for $4. That's not the answer. What are you going to do? You got to go back here. Ticket price. Remember, it was $10 and we went down 50 cents 4 times. So what do you get to? Even mental math here, if you go down 50 cents, you get to $8. 50 cents, 50 cents, 50 cents, 50 cents, $8. Okay, what if I had asked you about revenue? You could have taken this x value and plugged it into R equals, right? R equals, that's revenue. So you just could have plugged 4 into that line. But I said ticket price, so you had to plug 4 in to that little chunk. Okay, please look at where you're plugging in. Okay, number 3, the sum of 2 positive numbers is 18. Can you write me math? Go. Sum of 2 numbers is 18. Write me something.
Blank plus blank equals 18.
Blank plus blank equals 18. You could have used different letters. I don't care. A plus B. Maximize the product. So I'm going to go M equals, for max product or whatever, you could use a P equals, whatever. Maximize the product of the first number multiplied by 3 times the square of the second number. Okay, now this is exactly the same situation of our area question. Why? Because I have a variable, a variable, a variable. I have 3 variables. You can only have 2. So which variable looks like it'd be easier to substitute for? I would say A is easier because if I substitute in for B, I'm going to have to do something squared and times it by 3. So I'm just going to try to replace A. What is A equivalent to if you could isolate A here? A is 18 subtract B. Okay, so exact same as area, length and width. Okay, right here, my math is going to make me distribute that. Oh, anybody? What's 18 times 3? What'd you get to? 54? $54b squared minus 3b cubed. Yay, we like that? Okay. What's going on if you were to graph this function? What do you already know? N shape, but negative. Okay, we are trying to get a maximum. So this is what I'm looking for, a maximum or a tangent line, right? Same idea, slope 0 for my tangent line idea. So my calculus work is I'm going to figure out the slope by deriving. So what is that, 108? Okay, derived, I put my derivative to 0. And what would I need to do in order to solve this? GCF, right? Can I pull a negative 9b out? Do you like that? Negative 9, and I pulled a b out. So I'd have to times it by does that work as a FOIL? Negative 9b squared is that, and plus 108b is that, right? Does that work? Okay, so b would equal 0 or b would equal 12. Okay, and I have to eliminate this. Why? Go back to the question and read me the first sentence. The sum of two positive numbers, is 0 considered a positive number? Nope. So 12 is one of the positive numbers, and a would be the value 6. Why? Because they have to add up to 18. Right? Good? 12 plus 6. Okay, last question. Grade 12 pre-calc question. Your favorite. Okay, remember what I did, grade 12. We had a paper and we cut little corners. Do you remember that? We cut those little corners off. Then what did I do? I folded my box up, remember? So if these are gone, those are gone, and then you flip this little chunk upward to create the box, right? Okay, what is the new wall of this box? Do you remember how to do that one? It started out as 16, and then we made a cut in this corner and a cut in this corner. Minus 2x. Because we took an x off and an x off, and now this flap, right? 16 minus 2x also, because it was a 16 by 16. Just be careful, it might be a different number. And what's the height when you flip it up? X. So we're maximizing our volume. Length times width times height. Okay, we are going to FOIL this little chunk here. Give me that. Whoops, there's a cube there, isn't there? FOIL, but then after, right? Now I distribute that x yet. Did everybody get to the same end as me there with the volume? Okay, what do you know about this? It's an n. What's the domain of this? What's the smallest amount of x? X is the cutoff piece. What's the shortest we could cut off?
approaching 0.
approaching 0. You can't cut off 0 and make a box, but you could do anything little bit. And you could approach not 16, 8. Right? Because you have to cut 2 of them off, so that's what you're thinking. Yeah. So if I cut off 8 and 8, that's cutting off 16, right? So you can't cut off 8, but you can get close to it. Okay, so just keep that in mind. Those are the x values. You can't be below that. You can't be above that kind of thing. Okay, so what are we going to do here? We are going to, obviously, derive slope stuff, right? Derive it to get a slope. So 12x squared minus 128x plus 256. 0 equals factoring. No, can't GCF.
Yeah.
Well, I mean, I could do like a 2, but I don't think that's really even going to help me. It's a complex trinomial. I'm actually tapping out of that. I don't want to factor. Quadratic formula. Let's just do it. Okay, ready? X equals opposite B. B squared minus 4AC over 2A's. Did you notice how I didn't do B squared? I just did like 128 squared there, right? Because I don't care about the negative squared, right? Is that okay with you? If you really wanted to, I could have put that in brackets, but like that. But that won't matter. Anyway, 128 plus minus square root what over 24? Oh, it would have been factorable, everybody, but that's okay. You know how I know? If this is a nice, perfect square rootable number, it would have been factorable, but that's okay. Practice. So I got 2 numbers out of that. What do we think about them? I don't really think both of them are going to work. 8 can't work because we said if you cut off 8 and 8, your whole side has disappeared, so that's not good on a box. And I'm just going to add centimeters to that as my answer about how much should I be cutting off each corner. Okay, so all of these problems you've developed equations for, whether it be in grade 11 or 12, now you just activate the slope derivative, zero it out to figure out that critical area. Okay, you get your critical x value, and then take your x value and answer your appropriate question with it.